Today I'll be doing Stephen Prairie Mass League, round number 117. Let's look at question 4. The figure below is a 5x5 grid. Each point to the nearest horizontal neighbor and vertical neighbors are 1 centimeter. And it is asking you how many ways are there to choose 2 distinct points from the grid so that they're integer distance apart from each other. So choosing P and Q is the same as choosing Q and P, which means don't count them twice. For example, if you were to choose this point to this point is the same thing as this point to this point. Okay, so how are we going to do this question? Let's calculate the horizontal ones first. Like the ways of choosing horizontally first. Let's look at one row. So let's look at this row. How many ways are there to choose? So if you want to choose 1 centimeter, then there will be 4 ways. This is 1, 2, 3, and 4. And if you wanted to choose 2 centimeters, there will be 3 ways. 1, 2, and 3. And similarly, 3 centimeters have 2 ways. And 4 centimeters have 1 way, which is the big one. So if we add them up, we have the number of ways you can choose horizontally, which is 10 for this row. And there's 5 rows, and all of them have the same reasoning of how many ways you can choose them. So that is 10 times 5. And for horizontal ones, they are actually the same because the choosing horizontally is just the rotated 90-degree version of choosing vertically. So if we have 50 ways to choose horizontally, then we're going to have another 50 ways of choosing vertically. However, the answer is not 50 plus 50 because we still have some cases left. For example, this is an example. This would be 5 centimeters, which is an integer. Because from using the Pythagorean theorem, we know that this is 3 centimeters, and this is 4 centimeters. Therefore, using the Pythagorean theorem, we know this is 5 centimeters. So we are not completely done yet. So the question is, how many ways are there to choose diagonally? So there's 2 types of choosing diagonally. For now, let's just focus on going from top left to bottom right, like this. So there's 4 more ways, which is this, and this, and this. So that is the 4 ways of choosing diagonally this way. And there's no other cases, because this one cannot move up, and it cannot go this way. So, and same as everyone else. For example, this point can go that way, but we already have the parallel version of this point. So there's no other cases. So we can say that the ones going down this way have 4 ways of choosing, which is these 4 ways. And the ones going up have also 4 ways, because because they're symmetrical, you can just reflect this and you'll get the ways of going up. Like, reflect this across this line. So it'll be like something like this, and like, wait, no. Like this, and something similar like that. That will be our 4-way going up. So if we add all of them together, we will get 108, which is the answer. Okay, so let's now take a look at question number 6. So this is question number 6. For a triangle ABC, sine A is this, and sine B is, the cosine B is this. Find the value of cosine C. One way of doing this is you figure out sine. You figure out A, and you figure out B, and then you use 180 to subtract from that to get C, and then cosine that. And if you were to type it in something like rule from alpha, so if you find the angle A, B, and subtract them from 180 degree, which is pi radians, because Wolfram alpha only take radians, and then you take the cosine of that, you will get your answer. But there's another way of doing it on paper. So the answer is B, as we can see, and the answer for the first one, for the fourth one is D. So this is what we can do without using a calculator. So the question is up here. Okay, so we know their ratios. The ratio between this and this is 3 and 5, because we know that sine is opposite over hypotenuse. So that will be their ratio. But the ratio for the other side is, it's 12 and 13 and 5. Because the ratio of cosine is adjacent over hypotenuse, which gives you 5 divided by 13. So how are we going to fit these two things together? We can do that by multiplying, by scaling up the 5, 3, 4 triangle by a factor of 4. So this 3 what becomes 2. This 3 what becomes 12, which is exactly the height of the other triangle. By the way, we got the height of the other triangle through Pythagorean theorem, because 12 squared plus 5 squared is equal to 13 squared. So let's do that. If this is 12, then this used to be 3, so we scaled this up by 4. So we have to scale this 4 by 4. So we get 4 multiplied by 4. And we have 5 multiplied by 4. So this is our new triangle. And now we're going to use something called the law of cosine, which says, let's call this side C, and this side A, and this side B. The law of cosine basically states that cosine of C, which is the angle which is the number that we cared about, this is equal to c squared, which is this length square. So this length is equal to 16 plus 5, which is equal to 21. So this states basically 21. So you have a squared plus b squared minus 21, and a is 13 squared, and b is 20 squared. And that divide by 2 times a times b, and b is 20, a is 13, and you will get your answer. Which is the one we did before, which is the one we got before, which is B. Okay, so that is how you could solve that, but on paper.